Hello everyone. I hope you all are fine there. So good evening guys. Please tell me whether audio and video is clear or not. Tell me everyone. Is my audio video clear? Tell me guys. Okay, thank you Ashok. Thank you. So good evening everyone. Good evening guys. So in today's session we will start with power electronics, and this session is about ISRO, and I have collected some questions, and those questions are previous year questions, so you can judge from these questions what is the level of the question that is going to be asked in the ISRO exam. But let me tell you guys, this time from power electronics you can expect 10 to 15 questions, because the syllabus is like this. In the syllabus it is written that the core subjects will be asked, 75% will be the core subjects, and the remaining will be the allied subjects to the core subject. It means core subject weightage is very high. It means the number of questions from power electronics, power system and machine, those questions will be very high in number. Okay, so you can prepare these three subjects and you can get good marks in this exam. Okay, so I have selected some questions. So these are again from previous year questions. Okay, so it's written by mistake. It's ISRO exam. Okay, so let's come to the introduction part. So this is my introduction guys, and my name is Asu Jangda. I teach almost every subject in electrical engineering, and let me tell you, those students who are going to prepare for GATE 2024, they can join this workshop. This workshop will be on 26th of May and at 7:30 p.m. This workshop will be taken by Abhinav Negi sir. So you can join this workshop, and you can get the idea how to conquer the GATE 2024, or what should be the ideas, how you should approach the exam. Okay, so it's a free GATE workshop. You can recommend to your friends also, to your juniors also, so that they can be benefited from this. Now let's say you are financially not that much strong, and if you want to join BYJU'S exam prep platform, so you can give the scholarship test. This test again you can get a scholarship up to 90%, and it will be on 28th of May 12 p.m. so you can register it. The link is given in the description of this video. You can go there, link for the scholarship test, and you can join us. Okay, so now it's time for Guru Dakshina. So you have to give the Guru Dakshina. You have to subscribe our channel, and don't forget to like this session. Press the bell icon so that you get the notification whenever my session will be live. Okay, so let's start guys. This is the first question on your screen, and with the help of these questions you will get the idea what kind of questions will be, I mean, what's the level of the question which is going to be asked in the ISRO exam. Okay, so this is the first question on your screen. I want you to solve this question. Do it fast everyone, do it fast. Please solve this question everyone, do it fast. This is a very easy question. A single phase full bridge rectifier circuit, okay, from a 220 volt 50 hertz supply, it consists of 4 diodes. It's an uncontrolled bridge. Okay, and the load resistance is 20 ohm and a very large inductance, so that the load current is constant. Load current is constant. It means the conduction is continuous. What is the average or DC output voltage? We need to calculate the average or the DC output voltage. Do it fast everyone. This is a very simple question. It's a very simple question. Do it fast. Let's see how many of you can solve it correctly. Do it fast, do it fast, do it fast, do it fast. Tell me guys, what is the correct answer? Tell me in the comment section, what is the correct answer? This is a very easy question. We have 4 diodes. We have 4 diodes connected like this. Okay, and here you have the AC source, and the load contains resistor and an inductor. Inductor is very high. It is given that the inductor is very high. We need to calculate average output voltage. We need to calculate average output voltage. Okay, now how to calculate average output voltage? V naught T average. We need to calculate this. V naught T average. Now tell me guys, What should be the correct idea? The conduction is continuous, current is constant. It is assumed that the current is constant. We know that since the diodes are there, so diodes are equivalent to thyristor if you take alpha equal to 0. If you take alpha equal to 0, then thyristor and diode, they have no difference theoretically. So it means that the output voltage wave shape will be like this. This will be the output voltage wave shape, and the average value of the output voltage will be 2 Vm by pi. Simple. And the value of Vm is 220 root 2. Okay. So what you can do is you can write 2 into 220 root 2 divided by pi. Okay. So this way you can solve it. Now, what is the approximate answer? I mean, you need calculator to solve obviously, but you can solve it with simple idea. Okay, 2 root 2 upon pi. Pi is 3.14 and this is approximately 1.5. 1.414 is 1.5 approximately. 1.5 into 2, that is you can say it's nearly 3, and this is 3.14. So approximately this ratio is 0.92 or 0.93. Okay. Now if you multiply 220 with it, obviously the voltage will be approximately 190, or because this is approximately 0.9, 0.92, 0.93. Okay. And if you multiply, I think you will get this answer, Calcutta. Okay. So roughly you can calculate. There is no need for calculator. Okay. I hope you got the idea. This question was very simple and you can easily solve this question. Let's come to the next question, guys. The next question on your screen is this. Again, in a single phase full wave controlled bridge rectifier. Now this time we have controlled bridge rectifier with a source inductance. So we have source inductance also. Okay. RL load. The load is given as RL. The output voltage during the overlap, the output voltage is asked. So tell me guys, which option is the correct answer? Which option is correct? Tell me. During the overlap interval, the output voltage is asked. So tell me what should be the correct answer. Everyone, do it fast. This is a simple question. This is very simple question. Do it fast, everyone. We need to calculate the output voltage during the overlap interval. So tell me, everyone. Tell me what should be the correct answer. Do it fast. Circuit is like this. Single phase. We have this source inductance and the load is RL. You can assume that the load current is constant. Okay, if L is very high. This is my LS. This is the circuit, guys. So tell me, during the overlapping interval, what happens? During the overlapping interval, we know that all the thyristors will be sorted. All thyristor will conduct. It means you can see that during overlapping, this will be sorted, this will be sorted, this will be sorted, this will be sorted. All thyristors will conduct during overlap interval. If this is sorted, this is also sorted, then the output voltage will be equal to 0. And the output voltage will be equal to 0. So during the overlapping interval, the output voltage will be 0. Answer is Calcutta. Okay. Answer is Calcutta. So you have to be very careful, guys. Don't put the answer in hurry. Okay. You have to be very careful. During the overlapping interval, all the thyristor will conduct. We know that. If all the thyristor conduct, it means it is sorted. It is also sorted. So the output voltage will always be 0. Okay. Let's come to the next question. The next question on your screen is this. Question number 3. The overdrive factor of a power transistor can be expressed. Now this is a memory based question. And I think it is ISRO, I don't know, I don't know which year is this, 2018 or 2017, I don't know in which year this was asked, but this is previous, these questions are previous year questions. Okay. So now tell me guys, how to solve this. Overdrive factor of a power transistor can be expressed as. How do you define overdrive factor of a power transistor? We know that if we have a transistor means BJT, let's say. If we have BJT, in BJT, base current and the beta are very important. base current and beta. Okay. Now under saturation there is again beta. Let's call beta set, and this is IB set. Okay, let's call it IB saturation. IB set. Now we know that the beta set, the beta under saturation is greater than beta, general normal beta. Okay, if the transistor is operating in saturation region, then the beta value is high. It means this IB set will be lower than this. Okay, IB set will be lower than this. Now that overdrive factor is greater than 1. It means it should be the ratio of IB upon IB set, because IB set is lower, because this beta is greater. Why? If beta is greater, why it's smaller? Because let's say you say that this is a collector current and collector current remains same. If collector current remains same, the base current in this case is IC upon beta. Here IB set is IC upon beta set. Since beta set is greater, then IB set will be lower. This is higher. So overdrive factor is greater than 1. So you have to take the ratio of IB upon IB set. Okay. This way you can remember it. Okay. I'm telling you the idea, just simple idea, because you have to remember it like this. Okay. So the correct answer is, tell me, it should be IB over IB set. Okay. Base current required to operate in saturation. Okay. Simple. This way you can solve it. Okay. So answer is Bombay. This question was very simple. Okay, this question was memory based question. I mean, you can't do anything about these questions. Okay, if you know this, you can attempt. If you don't know this, you have to skip. Okay, so these type of questions you need to revise. Okay, let's come to the next question, guys. The next question on your screen is, tell me which option is correct. Which power semiconductor device having highest switching speed? Tell me which device has the highest switching speed. Tell me, everyone. Tell me, guys, which device has the highest switching speed? Tell me, everyone, which device has the highest switching speed? Do it fast. Do it fast, everyone. Do it fast. Tell me the correct answer. Which device, which semiconductor device have the highest switching speed? Obviously, MOSFET. Yes. MOSFET is the correct answer because it has the highest switching frequency. Okay, so that's why we generally use MOSFET in many devices. Okay, MOSFET has the highest switching frequency. Okay, so just remember it. Now let's come to the next question, and the next question on your screen is this. By considering the standard notation, reverse recovery time of a power diode is. Now tell me which option is correct. Which option is correct? Tell me, guys, which option is correct? Now this is ISRO 2020. Okay, this question was asked in ISRO 2020. I don't know, it's in ISRO 2020, I don't know, but the previous question was in ISRO 2020. I don't know about this the year of the question, but I'm sure that this question was in ISRO 2020. Okay, this question was in ISRO 2020. Now let's come to the next question, guys. Tell me which option is correct. For a power diode, we need to check how to calculate reverse recovery time. Now this concept is very simple. We know that if the diode is conducting, then the current is like this, and if you want to reverse bias it, then this will be the phenomena, and this time is known as reverse recovery time, TRR. Okay, this time is known as reverse recovery time, and this current is known as peak reverse recovery, peak current you can say, because this is the diode current ID. So when the diode is conducting, when the diode is on, this current is this. Okay, the current flowing is this. And if the diode is reverse biased, let's say, then the current will go like this. It means in reverse direction it will conduct for some minute time. That is known as TRR. This is called reverse recovery time. Now, how to calculate this reverse recovery time? We need to check that. Okay, how to check it? It's very simple. What we can do is, first of all, We know that the reverse recovery charge QR, you can say the charge stored in the junction of this PN this diode is the area of this region. That charge should be removed from the junction. Then only the blocking capability can be attained. It means in the reverse recovery time, this much of charge has to be removed. Now, how to calculate this QR? Reverse charge or reverse recovery charge, you can say. That will be equal to the area of this triangle. So area of the triangle is, you can treat this like triangle. It's not exactly triangle, but you can treat it like triangle. So it will be 1/2 into TRR into this peak value. Peak value is, let's call IRM, reverse maximum current. Let's call it IRM. Okay. So the area of this is this QR you can calculate. Now, from here you can see that TRR is equal to 2QR upon IRM. Fine. So we found TRR in terms of IRM, in terms of this peak value of the current, but options are not given in this form. Now we need to change the option accordingly. We need to change this answer accordingly. Now how to change that? If somehow we can calculate the rate of change of this, so we can say that if we know this di by dt, if we know the slope, what is the rate at which the current is going down? If you know di by dt, multiply by this time, you will get this IRM. Okay, you'll get this IRM, simple. But this time, we don't know this time. Actually, we know this time is TRR. But let me tell you guys, this time is very less. The maximum time in TRR is this time only. So you can say that this time is approximately equal to TRR only. So what I'm doing is, I'm multiplying this slope with TRR. And it will give us IRM. It will give us this current IRM. Okay. Now from here you get the IRM value. You can put it here. So if you put it here, you will get 2QR divided by TRR into di by dt. That is equal to TRR. Now you can take this TRR on this side. It will become TRR square. Okay. So you can say that TRR square will be equal to 2QR divided by di by dt. Okay, now you can take root on both sides and you can calculate TRR. So the correct answer is, I think, Agra. Okay, so Agra is the correct answer. So this was a simple question, but you have to think about this question. Okay, so these were the 5 questions, guys, and I found only these 5 questions in last year. But this time, let me tell you guys, this time the number of questions will be high. You can't expect that only 2 to 3 questions will be asked. It might be possible that they are going to ask you about 10 to 15 questions from power electronics. And the level of the question is exactly same. You can't take difficult question in power electronics. The reason is, if you frame a numerical question, it will be lengthy. And the time is not that much in ISRO exam, especially because you know that the number of questions are very high. The time is not, on an average, on each question you need to devote 1 minute. So the level of the question will be like this only. Okay, it will be a simple level, so you have to be very clear and you have to remember all these small things. So revise your subjects accordingly, because you don't need to go into depth concept. Okay, you need to revise all the formulas, you need to remember all the formulas, you need to remember all the small things, so that you can attempt the exam better. Okay, so this is my advice. Okay, now it's time to end this class, because this class was very short duration, because only 5 questions I got. So I have solved these questions. Now it's time to subscribe our channel. So you have to subscribe our channel and like this session. If you have not liked it, press the bell icon so that you get the notification. And we have our mobile app, BYJU'S Exam Prep mobile app. Okay, so don't forget to install this mobile app. On this mobile app, again, we are teaching free, so you can join those sessions also. And I'm taking some trick related sessions on mobile app, so you can join this. So better you install this mobile app, and then you can attend my classes on mobile app also. Okay, So that's all for today's session, guys. I hope you enjoyed. See you in the next session. Take care and bye.